So is it visible, my PPT? Hello. Is it visible, my PPT? Dr. Raut, is it visible? Okay, it is visible. So I will start my talk. So my topic is the introduction to machine and deep learning and applications to biomedical image analysis. So in this talk, mainly I will briefly discuss some very fundamental topics of machine learning and deep learning. Many of you might know all these concepts, but since it is a popular talk, so I will be covering the basic concepts. I will show some of the applications of machine and the deep learning in biomedical image analysis. So what is machine learning and what is deep learning? And after this, I will explain the applications to biomedical image analysis. So first, let us define what is computer vision. So that is the definition. If you see, that is the building machines at sea. So I want to develop a machine which is very much similar to human visual system, and this machine can interact with world. And input to a computer vision system is images and the videos. And computer vision is nothing but the modeling of biological perception, like human visual system. So this is the standard definition of computer vision. So let us see what is the similarity between computer vision and the human visual system. So in the next block diagram, this block diagram, you can see I want to show the similarity between the human visual system and the computer vision system. In the first block diagram, you can see this is the human visual system. We have eyes, so we can see objects, we can see images, we can see videos. After this, we do some processing in our brain, and after this, we take intelligent decisions in our brain. That is about the human visual system. And if you see the next block diagram, that is the computer vision system. So this is very similar to human visual system. So we have cameras. Maybe we may have only one camera, single camera, or maybe multiple cameras. And for by using these cameras, we can get the images, we can get the videos, and after this, we have to do some pre-processings. That is the image processing we have to do. And finally, we have to apply the machine learning algorithms, the artificial intelligence algorithm, for decision making. So if you compare these two structures, they are very similar. One is the human visual system, another one is the computer vision system. So for computer vision, if I consider one biomedical image analysis, the block diagram is this is the block diagram. So we have the camera, and by using this camera, we can capture the images, we can get the videos, and after this, we have to process the images, we have to process the videos, and finally, we have to apply the machine learning algorithms, the artificial intelligence algorithm for decision making. Now, I want to show the distinction between the computer vision, image processing, and computer graphics. In case of the computer vision, my input is image and the output is interpretation. The interpretation of the image, the interpretation of the video. So that is the computer vision. So I can say it is the image analysis, image interpretations, or maybe the scene understanding. So that is the definition of the computer vision. The input is image and the output is the interpretation of the image, interpretation of the video. In case of the image processing, my input is image and output is also image. So I can give some examples like image recovery, image reconstruction, image filtering, image compression, image visualization. So I can consider these examples. So in case of the image processing, input is image, output is also image. Next one is the computer graphics. In computer graphics, input is the scene or maybe the model. So I can consider a model, and from the model, I have to generate the image. So that is the computer graphics. From a given model, I have to generate the image. So you can see the distinction between computer vision, image processing, and computer graphics. So there are many applications of computer vision. You can see like the human computer interactions, biomedical image analysis, video surveillance, security. In multimedia applications, there are many applications of computer vision image processing, and also like the visual navigation, augmented realities, optical character recognition, 3D object recognition, games, 3D reconstruction, image segmentation, and maybe the industrial inspection of components, and automation and robotic automations. So there are many applications of computer vision. There are many applications of the image processing. So in my talk, this talk, mainly I will consider the biomedical applications. So this is a typical block diagram of a image analysis system. So here you can see the image analysis system is the computer vision. So from the block diagram, you can see the input is the image. That is the image pre-processing. And after this, we have to do the segmentation. Segmentation means the partitioning of an image into connected homogeneous region. So we can do the partitioning of an image into connected homogeneous region. After this, we have to extract the features. So here you have seen, you see here the x1, x2, xn. These are the features, and this is nothing but the feature vector. So we have to extract the feature, and finally, with the help of this feature vector, we have to do the classification. So I may consider one biomedical image, and maybe suppose if I want to consider the classification of the benign tumor and the malignant tumor. So in this case, what we have to do first, we have to capture the image. After this, we have to do the segmentation. We have to do the image processing, and finally, we have to extract the features. And based on these features, we have to do the classification. So this is a typical image analysis system. So some applications I can say like this. Some biomedical examples like in laparoscopic surgery, or maybe the recognition of the brain tumors, and maybe that virtual surgery. You can see there are many applications of computer vision, many applications of the artificial intelligence in biomedical image processing. And this is one example. Here you can see it is a 3D imaging, MRI or the CT scan, that is the computed tomography. And in this case, this is the image guided surgery. So maybe we can detect the tumors in the brain, or maybe we can detect the malignant tumors and the benign tumors in the brain. So this is one example of the medical imaging. And another example is the chromosome analysis. So that is also one important biomedical applications. And also the 3D medical images. Maybe we can consider the MRI or the CT scan. That is the magnetic resonance imaging, and another one is the computed tomography. So these images we can consider. And this is one example of the robotic joint replacement surgery. So that is one application. So in this application also we can apply computer vision, image processing, and finally we have to apply machine learning and the artificial intelligence. And also you can see another example, a detection of the tumors in the brain. So you can see the tumors are detected, and for this we have to do some pre-processings. Maybe we have to do the segmentation, and after this we can identify the tumors in the brain, and that is automatic identification of tumors in the brain. And also you can see this is another example how to detect the tumors in the brain. So these are some simulation results. And also this is another application, that is the blockage in the arteries and the veins. So this also we can determine. So you can see the original image, and after the processing we can detect the blockage. There may be some blockage in the veins or maybe the arteries. Mainly we will consider the arteries. So that blockage we can also determine with the help of computer vision, image processing, and finally, because anyhow we have to apply machine learning and artificial intelligence. So what is artificial intelligence? So if you see these definitions, the programs with the ability to learn and reasons like humans, and that is the standard definition of artificial intelligence, AI. And if you see this figure, you can see the machine learning is a subset of artificial intelligence. So machine learning, maybe we can consider the statistical machine learning techniques, or maybe the supercomputing based. Hello, 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 hello. There is a noise in the background.
Sir, you please proceed, we'll check it.
There is a noise, continuous noise in the background. Please check this.
I think now it's okay, sir.
Yes, yes, it is fine. So you can see here, after this I have shown the machine learning. So machine learning is a subset of artificial intelligence. So we may consider statistical machine learning techniques, or maybe the syntactic machine learning techniques, or maybe the soft computing based machine learning techniques. Soft computing means we can consider the artificial neural networks, the fuzzy logic also we can consider, or maybe we can consider genetic algorithms or the genetic programmings. And deep learning is a subset of machine learning. So mainly we will consider the artificial neural network and the extension of the artificial neural network in the deep learning. So you can see this classification. One is the artificial intelligence, one is the machine learning, another one is the deep learning. So for machine perception, so to build a machine that can recognize patterns. So what is the definition of the pattern? So if I consider suppose a signal, or maybe if I consider the ECG signal or maybe the EEG signal, that I can consider as a pattern. In case of the image, if I consider the fingerprint, one fingerprint, so that I can consider as a pattern. So in case of the speech recognition, in case of the fingerprint identification, in case of the optical character recognition, in case of the DNA sequence identification, in case of the biomedical image processing, in case of the biomedical signal processing. So there are many applications of machine perception. And this is very similar to human perception. Suppose if I want to learn alphabets of the English language, so first I have to train ourselves to recognize alphabet. First I have to do the training, and after this training, suppose a new alphabet is coming, then from my intelligence, from my memory, I have to recognize it. So that is the human perception. In case of the machine perception, the concept is very similar. First I have to do the training, and after this we have to do the testing. In case of the human perception also, if I consider this example, that is the alphabet recognition. So first I have to do the training, and after this, suppose a new alphabet is coming. So this new alphabet I can recognize based on my intelligence from my memory. I can recognize. That is the machine perception. So you can see for machine perception also we have to do the training, and after the training we have to go for testing. Testing means recognition or the classification. So the definition of the pattern recognition is first is what is the definition of the pattern? So pattern is an object, process or event that can be given a particular name. So already I have defined the pattern. The pattern may be a signal, the ECG signal or EEG signal, or maybe the fingerprint, or maybe the face image I can consider as a pattern. And after this, next one is the pattern class. That is the set of patterns sharing common attributes. That is the definition of the pattern class. So suppose if I consider the fingerprint of school employee, or maybe the faculty members of the electronics department, that may be a class, the pattern class. So you can see the distinction between pattern and the pattern class. And after this, we have to go for recognition. We have to go for classification. So for this, we have to consider the classifier. So in machine learning, already I have explained, that is, we can consider statistical machine learning algorithms, or maybe the syntactic machine learning algorithms, or maybe the subcomputing based machine learning algorithms for recognition, for classification. So these are the approaches. One is the statistical pattern recognition techniques. So maybe the simple one is the Bayes classifier. So we can consider the Bayes classifier because we know the Bayes theorem, and with this we can consider the statistical pattern recognition problem. That is very popular. The another one is the syntactic pattern recognition technique. that is the structural pattern recognition technique. That is nothing but the description of a particular pattern. So suppose if I consider A, so A means I need two vertical lines and one horizontal line. To define the pattern A, I need two vertical lines and one horizontal line. So with this, I can describe a particular pattern. The pattern is A. So that is actually the structural pattern recognition. Nowadays, it is not much of use. And finally, we can consider the artificial neural networks for pattern classification. So the extension of the artificial neural network is the deep learning. So these are the approaches of pattern classification. So here you can see the block diagram of a pattern classification system. So first I have the patterns. So from the patterns, I can take some measurements. That means I can consider some sensors. So with the help of these sensors, I can take some measurements and I'll be getting the measured values. And from the measured value, I can extract the features. These are the features extraction. So feature extraction. And after this, I'll be getting the feature values. And one important point is all the features for a particular pattern classification problem may not be important. So we have to select the best features which can give the maximum accuracy. So that is why feature selection is important. For a particular pattern classification problem, if I consider many features, that may not improve the classification accuracy. So that is why we have to reduce the dimension of the feature vector. We have to select the most important features. Most important features means the most discriminative features. And so the selection of the most discriminative features, it is quite important. So that is called the feature selection. So if I increase the number of features for a particular pattern classification problem, and suppose the number of training samples are very limited, then in this case, I may not get very good accuracy. The accuracy will drop. This problem is called the curse of dimensionality. The curse of dimensionality. The curse of dimensionality is called, suppose if I consider many features for a particular pattern classification problem, and I have limited number of training samples, then what will happen? The accuracy, the recognition accuracy may not improve. And this is called the concept of the curse of dimensionality. So that is why all the features may not be important. So we have to consider the most discriminative features for a particular pattern classification problem. So I'll be getting the feature vector. The feature vector is X. And you can see here, this is the classifier I'm considering. And we have the database and the rules. And based on these rules and the database, first I have to do the training, and after this we have to do the testing. So we can go for classification. So that is the decision making. And one is the hard decision making. So hard decision making means I have a decision boundary between the classes, and there is no possibility that one particular sample belonging to a particular class may belong to another class. There is no possibility. But in case of the soft decision, that is the fuzzy decision, there is a possibility that a particular sample belonging to a particular class may belong to another class. There is a possibility of this. So this possibility is actually defined by the membership grade in fuzzy membership grade. So that means there is a possibility that particular sample may belong to another class. That possibility is determined by the membership grade. So membership grade lies between 0 and 1. If the membership grade is suppose 1, that means the highest possibility. If the membership grade is 0.1, the possibility is very less. So that means in case of the soft decision, there is a possibility that a particular sample may belong to another class. But in case of the hard decision, that is not the case. So you can see the decision making in this case. And how to define a pattern classification problem. So you can see here, I am considering the classes. The classes are Wi, Wj, Wk. So here I am considering these classes Wi, Wj, Wk. This is called the class membership space. This is called the class membership space. And after this, I am considering the pattern space. So P1, P2, P3, P4, these are the pattern space. These are the patterns. And after this, I am considering the measurement space M1, M2, M3. So I have three measurements. one is M1, another one is M2, and another one is M3. And you can see the patterns of different classes are overlapping. Here you can see the patterns P1 and P2, that is overlapping. Pattern P2 and P3, that is overlapping. So what is the meaning of this? The meaning is the patterns of different classes may share common attributes. So that is why the overlapping is taking place. So patterns of different classes may share common attributes. So that is why you can see the P1 is overlapping with P2, P2 is overlapping with P3. So corresponding to the class Wi, I have two patterns. The pattern is P1 and P4. Corresponding to the class Wj, my pattern is P2. Corresponding to the class Wk, the pattern is P3. And corresponding to the pattern P1, the measurement is M1. Corresponding to the pattern P2, the measurement is M2. And corresponding to the pattern P3, the measurement is M1. Now, what is the definition of the pattern classification? In this case, you can see this is not one-to-one mapping. This is not one-to-one mapping. Had it been one-to-one mapping, the pattern classification problem would have been very, very easy. But it is not one-to-one mapping. So what is the definition of the pattern classification? The definition is, from the given measurement, I have to determine the corresponding class. So I have the measurements. The measurement is M1, M2, M3. From the measurement, I have to determine the class. The class is Wi, Wj, Wk. So it is not one-to-one mapping. So I can define the pattern classification problem like this. So from the given measurement, I have to determine the corresponding class. And mathematically, I can describe like this: the probability of Wj given x. X is the Fisher vector. So I have to determine the probability of a particular class. The class is Wj. And given the Fisher vector, the Fisher vector is x. That I have to determine. The probability of Wj given x, that I have to determine. So from this figure, you can see the definition of the pattern classification. So already I have shown this one. Again, I am showing here the patterns are available, and the sensors and the pre-processing. Mainly, we have to consider the measurement. So for measurement, I am considering the sensors and the pre-processing. After this, we have to consider the feature extraction, and finally, we have to consider the classifier. So for this, we are considering the learning algorithm. So for learning algorithm, we may consider two approaches. One is the supervised technique. Another one is the unsupervised technique. In supervised technique, we know the class levels. The training samples are available, and corresponding to these training samples, we know the class levels. So what are the classes we know corresponding to a particular training sample? And based on these training samples, we have to train the classifier. So that is the supervised training. In supervised training, we know the class levels, and also the training samples are available for each and every classes. For each and every classes, the training samples are available. So that is the supervised learning. So we know the class levels, and corresponding training samples are available. So with these training samples, I have to train my classifier. In case of the unsupervised technique, I do not know about the class levels. I do not know about the class levels. So what is available? The Fisher vectors are available. So I have the Fisher vectors, and I have to group the Fisher vector based on some similarity. That is the unsupervised. So I am repeating this. In case of the unsupervised, I have the Fisher vectors, and I have to group this Fisher vector based on some similarity. I do not know about the class levels. So you can see the distinction between the supervised learning and the unsupervised learning. In unsupervised, we do not know about the class levels, but we have the Fisher vectors. So we have to group the Fisher vectors based on some similarity. That is the supervised and the unsupervised. So here you can see I am showing a very simple classification problem. That is, the problem is the jockey and the hoopster recognition. So I have two classes. One is H, another one is J. And for this, I am considering two features. One is the height, another one is the weight. So x is the feature vector and it has two components. It has two elements. One is x1, another one is x2. So based on this, you can see I am considering one linear classifier. So I am considering a decision rule. The decision rule is w dot x, that is the dot product, w dot x, w is the weight vector, dot x plus b is the bias. If it is greater than equal to 0, then the corresponding class will be h. And if w dot x plus b less than 0, then the corresponding class is j. So with the help of these decision rules, I can do the classification, and I have two classes. One is h, another one is j. And you can see I have shown the feature space. The feature space is x1 and x2. You can see, and I am showing the decision boundary between the classes. One is the blue class, another one is the red class. W dot x plus b is equal to 0. That is the equation of the decision boundary. W dot x plus b is equal to 0. That is the equation of the decision boundary. The left side is the deep networks, and another one is the shallow. Support vector is shallow, but if I consider the autoencoder or maybe the convolution neural network or maybe the recurrent neural networks, these are deep networks. But if I consider the GMM or maybe the restricted Boltzmann machine or maybe the support vector machine, these are the shallow techniques. And also you can see the classification is supervised and the unsupervised. So one is the supervised, another one is the unsupervised. In case of the neural networks, we have the supervised neural network. Also, we have the unsupervised neural networks. So I will explain what is the supervised artificial neural networks and what are the unsupervised artificial neural networks. And also the support vector machine you can see. And unsupervised is mainly you can see the Gaussian mixture model neural networks like this. These are the classifications. And one is the probabilistic model. If you see the base NP or the restricted Boltzmann machine GMM, these are the probabilistic models. So machine learning, popular machine learning algorithms are like this. The supervised and the unsupervised. Reinforcement, I will discuss later on. What is the reinforcement learning? So one is the regression, that is the supervised technique. That is the linear regression or the polynomial regression. Decision trees, random forest, classification, maybe we can consider K nearest neighbor, KNN. Decision trees, logistic regressions, naive Bayes, we can consider the support vector machine. In case of the unsupervised, we can consider singular value decomposition, SVD, very important. Principal component analysis, K means clustering, a priori, we can consider FB growth, also you can consider. Also very important is hidden Markov model. Hidden Markov model is very important, that is unsupervised. So I will discuss about the reinforcement later on. So you can see this is the classification, the supervised and the unsupervised. So machine learning, already I have explained, the basics is we have the label data and we have the machine learning algorithms. So with this label data, we have to train the model. So that is the learned model we are obtaining after the training. So you can see the label data is available, and after this we can go for classification, we can go for prediction, we can go for recognition. So this is one example of the supervised training, supervised learning. And here I'm showing this one. So one is the classification problem. The classification, two classes I am considering, class A and the class B. Regression is nothing but fitting of a line or fitting of a curve between the sample points. So you can see these are the sample points, and I want to fit a line that is the best fit line I want to fit between the sample points. And finally, we can see that is the clustering we can see. So that is the clustering, that is the grouping. So in case of the traditional pattern recognition, what we have to do, from the input image or from the input signal, I have to extract the features. These features are called the handcrafted features. Maybe we can consider the shift features or maybe the hog features. Shift is the scale invariant feature transformation, the histogram of oriented gradient. And after this, we can apply the K-means clustering, that is the unsupervised. And after this, we can apply the supervised technique. So this is the traditional pattern recognition system. So we have to extract the handcrafted features, and after this, we have to apply the pattern classification algorithms. So already I have given the distinction between the machine learning and the deep learning. In case of the machine learning, first we have to extract the features, and after this we have to go for classification. In case of the deep learning, we have the input image, and already I have mentioned the deep learning is nothing but the cascade of nonlinear transformations. That is the hierarchical model. So that means more and more important information from the input image can be extracted. So I can extract more and more information from the input image, from the input signal, I can extract. Maybe the low frequency information, maybe the mid frequency information, or maybe the high frequency information I can extract from the input image. So here also I have shown the deep learning. The input image is this, and I am extracting the low frequency information, that is the low level parts, the mid level information that I can extract, and also the high level parts. So high level information means the high frequency information. Maybe we can consider the boundaries or maybe we can consider the edges, or maybe some the boundaries edges like this. The high frequency information we can consider. Low level parts means the low frequency information we can consider. So this is the deep learning model. So if I consider the deep learning versus machine learning, so these are the factors. What are the factors I am considering? One is the data requirement, and one is the accuracy, one is the training time, one is the hardware dependency, and another one is the hyperparameter tuning. So in case of the deep learning, data requirement is more. We need the large amount of data. In case of the machine learning, it can be trained on lesser data. Accuracy is very high in case of the deep learning as compared to machine learning. Training time is very long. Training time is very long in case of the deep learning. In case of the deep learning, we need a GPU, but in case of the machine learning, the CPU is sufficient, one CPU. And in case of the hyperparameter tuning, so we can these hyperparameters can be tuned in various different ways. So these hyperparameters we can train. There are different techniques for tuning of these hyperparameters. But in case of the machine learning, limited tuning capabilities. So this is also important, very important, that is hyperparameter tuning. So these pattern recognition algorithms, we have the bag of algorithms, and these algorithms have solid probabilistic framework, and algorithms work on certain characteristics defining a class referred as features. So this concept already I have explained. And what is the features? Suppose if I want to classify these two patterns, one is the capital I, another one is the small I. So you can see the presence of dot can distinguish the capital I from the small I. So this dot can be a feature because the presence of this dot can classify these two patterns. One is the capital I, another one is the small I. So that is the presence of dot in I can distinguish this small I from the capital I. So that I can consider as a feature. And feature values may be discrete or continuous. And in practice, a single feature may not be sufficient for a particular pattern classification problem. For proper discrimination, a single feature may not be sufficient. So finally, I want to show the block diagram of this. So input signal is available, and after this we have to do the measurement. After this we have to do the segmentation. In case of the image segmentation, that is nothing but the partitioning of an image into connected homogeneous region. That means the segmentation of the foreground from the background, segmentation of the foreground from the background, and after this we have to extract the features. And after this we have to do the classification, and the post-processing is nothing but I have to determine the cost. That is the classification accuracy. What is the good accuracy or the bad accuracy I will get, that I have to determine. And based on this, I can give the feedback to the input steps. Maybe I can give the feedback to the feature extraction step. I can give some feedback to the classification step. Like this, I can give some feedback. So these discriminative features already I have explained. These features should be invariant with respect to affine transformation. So if I consider the affine transformation, maybe the translation we can consider, rotation we can consider, the scale also we can consider. The feature should be discriminative, and it should be invariant to this affine transformation. And also in case of the image processing, this feature should be invariant to photometric variation. That is illumination variation we have to consider. So this feature should be invariant to affine transformation. The feature should be invariant to photometric variations that we have to consider. So after this we have to do the classification, and after this we have to consider the post-processing. That is nothing but the feedback to improve the performance of the algorithm. So training already I have explained. So first we have to do the training. So supervised and unsupervised concept already I have explained. So in case of the supervised, we have the class levels. In case of the unsupervised, we have the feature vectors, and we have to group the feature vectors based on some similarity. So this is the unsupervised. Unsupervised is nothing but natural groupings. So clustering is, what is the clustering? So in case of the clustering, we have to see high intra-class similarity. That means for grouping, we have to see a high inter-class similarity, and also we have to see the low inter-class similarity. That is also important. For clustering, we have to consider this. One is the high inter-class similarity, another one is the low inter-class similarity. So we have to do the grouping based on some similarity. This similarity measurement we can consider by considering the distance measure. Maybe I can consider the Euclidean distance we can consider for this measurement of the similarity. So maybe we can consider the Euclidean distance like this we can consider. So here you can see the clustering is subjective. Why it is subjective? You can see from the input images, I am doing different groupings. Many groupings I am doing. One is the family I am considering. That is the group of a family. Another one is the employee, school employee that we are considering. Another one is the females group. Another one is the males group. So that is why I can say the clustering is subjective. So already I have explained. So based on some similarity, we have to do the grouping. So here you can see I am showing two images. So I can find the distance between these two, and I can find the similarity score. Similarly, between these two, Peter and Peter, I can find the similarity between these two. So for this, I can determine the distance measure. And similarly, between these two fingerprints, I can find the similarity. I can find the similarity between these two fingerprints. So one popular algorithm is the k-means clustering. So I think many of you know about this k-means clustering, very simple algorithm. So for this, we have to consider the number of centroids. The number of centroids is k. And also randomly, we have to initialize k cluster centers. So that is very important. Randomly, it is important. Randomly, we have to initialize the k cluster centers. So this algorithm, next slide I can show you. So this one point is very important. So randomly, I have to initialize k number of centroids. So here you see I am showing the sample points. Sample points I am showing, and I am considering, suppose, three clusters I am considering. So K1, K2, K3, these are the cluster centers. Three clusters I am considering. So corresponding to cluster 1, the K1 is the centroid, K2 is the centroid for the second cluster, K3 is the centroid for the third cluster. After this, what I have to consider? I have to find the distance between the sample points and the centroid. And I have to determine whether a particular sample point belongs to a particular cluster. That I can determine based on the distance. If suppose the distance between a particular sample point and the cluster centers, I have to determine. And suppose the minimum distance I am obtaining for the centroid K2, that means that particular sample point will belong to that cluster center. So based on this distance, I can assign a particular sample point to a particular cluster. So based on this distance measure, I can do this assignment I can do. So particular sample I can assign to a particular cluster based on this minimum distance. So I have to find the distance between the sample point and the cluster center, K1, K2, K3. So which one is minimum, that I have to determine. And suppose the K2 is minimum, that means that particular sample points will belong to cluster K2. So like this I have to determine. After this, I have to recompute the centroids. After doing all this case, after doing for all the samples, I have to recompute the cluster centers. And this process I have to do iteratively. So iteratively, I have to do this process until there is no change of the centroid. So finally, the centroid will be almost same. There will be no change of the centroid. So at that point, I will stop the iteration. So I will stop my iteration at that point. So here you see. So these are the initial centroid K1, K2, K3. And I have three classes. One is the green, another one is the red, another one is the blue. And after this, I have to find the distance. So here you see. After finding the distance, I am assigning the sample points to the different clusters based on the minimum distance. And after this, I am recomputing the centroids. So these are my new centroid, K1, K2, K3. After this, again, I have to see, you see, initially the red, this green one, it was assigned to the cluster K1. But after this, you can see this green is assigned to the cluster K2. So I have to do this for all the sample points. And after this, again, I have to recompute the centroid. So I am recomputing the centroid like this. So I have to do it iteratively. And I have to do like this. And finally, I will be getting the cluster centroids. So these are the clusters I am getting, K1, K2, K3. These I am getting. So in this case, you can see the distinction between supervised and the unsupervised learning. So you can see in case of the supervised learning, I have the classes, dark, dark, not dark, not dark. And I am considering the supervised learning, and I am having the predictive model. So first I have to do the training with the known class levels. And after this, with the help of this learned model, that is the predictive model, I can do the classification. In case of the unsupervised one, just I am doing the clustering, I am doing the grouping. This is also unsupervised, just I am training data set is available, and I am just doing the grouping. Now, sometimes it is very difficult to find the similarity between these type of images. So how to find the similarity between these two images? That is also one research problem. So how to find the similarity between these two? So very difficult to find the similarity between these two, but you can do the grouping. So you can, with the help of the grouping, you can see the similarity and the dissimilarity between these two images. The next one is the reinforcement learning. So the fundamental concept of the reinforcement learning is mainly one action, particular action, that is the classification action, is not so important. The group of actions are more important, because our goal is a particular goal we have to reach. So goal is more important, and one particular action is not so important. The group of actions, that is more important. So we have to take very good actions to achieve a particular goal. To achieve a particular goal, we have to take the good actions. So I can give one example. Suppose playing of a chess game. So one action, one move may not be a good move, but the group of actions, the group of moves are more important, because the goal is I have to win the game. So the playing of a chess game, that is one example of the reinforcement learning. So corresponding to a good action, I will be getting a reward. So if I have a good action, I will be getting a reward. And based on this, I have to select the best action. So best action I have to consider. So the main concept is, the fundamental concept is, the one particular action is not so important. The group of actions are more important, because I have to achieve a particular goal. So this is the fundamental concept of the reinforcement learning. And another one is the semi-supervised learning. That is also very important in case of the biomedical image analysis. In case of the biomedical image analysis, we do not have the so many level data. Very difficult to get the level data. If I consider, suppose, the endoscopic images, endoscopic video, the colonoscopic images, colonoscopic videos, very difficult to find the level data. So in this case, in case of the semi-supervised learning, what is the case? The semi-supervised learning is basically in between the supervised learning and the unsupervised learning. So in case of this, we have a small amount of label data, and we have a large amount of unlabeled data. That means we have the small amount of label data and a large amount of unlabeled data. So one example already I have given. Suppose in case of the medical image analysis, it is very difficult to get a good amount of, large amount of label data. So we may have a small amount of label data may be available, and with a large amount of unlabeled data. So we have to do the classification with this help of the label data and the unlabeled data, and that is called the semi-supervised learning. The semi-supervised learning is very important in case of the biomedical image analysis. or maybe biomedical signal processing, because it is very difficult to get the level data. And regression, already I have mentioned, that is nothing but the fitting of a line or fitting of a curve between the sample points. So one is the polynomial fit I can consider. So mathematically I am not explaining all these things, but for this talk, popular talk, so just I am explaining the concept. So already I know that many of you might know all this concept, but just I am giving the overview of all the techniques. And this is the classifier. You can see I am showing the decision boundary between the two classes. One is the red class, another one is the green class. And you can see the decision boundary between the classes. And one thing is very important, that is there are two types of classifier. One is the generative classifier, another one is the discriminative classifier. If you see in the Bayes law, so if I want to determine the probability of Wj given X, so what information I need? I need the information of the likelihood, that is the class conditional density, the probability of X given Wj, that information I need. And another information is the probability of Wj, that is the prior probability. But the one important thing is the probability of Wj given X, that information I need. So that is called the class conditional density, that information I need. So in case of the generative classifier, we need this information, that is the probability of probability of X Wj, probability of X Wj, probability of X given Wj, that information is important to determine probability of Wj given X. So we need that information, that is the probability of X given Wj. And in case of the discriminative classifier, we do not need that information. So we do not need the information of the class conditional density. So with the help of some algorithms, we have to find the best decision boundary between the classes. So one example is the support vector machine. In case of the support vector machine, we do not need the information of the class conditional density. So we need the information, we do not need that information, that is the information of the class conditional density, and we have to find the best decision boundary between the classes. That is the discriminative classifier. In case of the generative classifier, there are two types. One is the parametric, another one is the non-parametric. So in case of the parametric, we know the class conditional density. Suppose the density is Gaussian density. In case of the Gaussian density, we have two parameters. One is the mean, another one is the variance. Or maybe if I consider the high dimensional case, then in this case it will be the mean vector and the covariance matrix. So in case of the parametric method, we know the class conditional density, but we do not know about the value of the parameters. So parameters are mean and the variance, or maybe the mean vector or the covariance. We do not know about this. So we have to determine the parameters. That is the parametric estimation. So parametric estimation is, we know the class conditional density. So then density may be different types of density. We can consider the Bernoulli density or maybe the Gaussian density. So one example is the Gaussian density. In case of the Gaussian density, the parameters are mean vector and the covariance matrix, or maybe the mean or the variance, that I have to determine. There are two popular algorithms for this. One is called the maximum likelihood estimation, and another one is called the Bayesian estimation. Very popular algorithms for estimating the parameters. One is the maximum likelihood estimation, another one is the Bayesian estimation. So in case of the maximum likelihood estimation, I have to determine the probability of d given theta. D means the training data set, and theta is the parameter vector. So I have to maximize probability of d given theta. So that I have to maximize. That is the maximum likelihood estimation. In case of the Bayesian estimation, I have to maximize probability of theta given d. Theta is the parameter vector. Theta is the parameter vector. So these two very popular techniques. One is the maximum likelihood estimation, another one is the Bayesian estimation. So generally, both the techniques are very important, but generally the Bayesian estimation gives more accuracy as compared to maximum likelihood estimation. The Bayesian estimation gives more accuracy as compared to maximum likelihood estimation. But the problem of the Bayesian estimation is, the computational complexity. So in case of the Bayesian estimation, we have to determine the multidimensional integration. The multidimensional integration we have to determine. So that is very difficult to determine. So there are some techniques like Monte Carlo simulation is also there. So by using this Monte Carlo simulation, we can determine this multidimensional integration. So in the books, you will get this information. So how to determine the multidimensional integration. Otherwise, the maximum likelihood estimation and the Bayesian estimation is almost similar. In one case, I have to maximize the probability of D given theta. D is the training data set. In case of the Bayesian estimation, I have to maximize probability of theta given D. That is called the parametric estimation. In case of the non-parametric estimation, that density information is not available. I do not know the class conditional density. So that information is not available. So I have to estimate the density. There are two popular techniques you can see in the books. So one technique is called the Parjan window technique, and another one is the K nearest neighbor technique. So with these two techniques, you can determine the density. Very popular techniques. One is the Parjan window, another one is the K nearest neighbor technique. So with this help of this, you can determine the densities. So you can see the distinction between the parametric method and the non-parametric methods. And one is the generative classifier, another one is the discriminative classifier. For the generative classifier, you need the information of the class conditional density. For discriminative classifier, we do not need the information of the class conditional density. So this already I have explained, generative classifier and the discriminative classifier. So generative classifier, we need the probability, we need the class conditional PDF. The class conditional PDFs are like this: probability of X given Wi, like this. So this information is needed, and based on this information, I can determine the discriminate function, and with the help of the discriminate function, I can do the classification. So this is one example of the generative classifier, and you can see the decision boundary between the classes. And already I have explained about the non-parametric and the parametric. So non-parametric approach, you have to determine the density. So already I have mentioned. So in case of this, you have to apply the Parjan window technique and the K nearest neighbor technique. In case of the parametric techniques, you have to estimate the parameters. So you can apply the maximum likelihood estimation or the Bayesian estimation. Next one is the discriminative classifier. So you have to find the best decision boundary between the classes. So you have to update the weights. So some initial weights you have to consider, and you have to update the weights. And by this, you can determine the best decision boundary between the classes. So maybe you can consider the support vector machine, or maybe the MLP, the multi-layer perception you can consider, single layer perception you can consider. So this you can consider for discriminative classifier. So here you can see I am considering two classes and I am finding the best decision boundary between the classes. So you can see the linearly separable data. I have two classes and I am drawing the decision boundary between the classes. This is linearly separable data. And for the linearly separable data, you can see I am considering W1 X1 plus W2 X2 plus B is greater than 0. That corresponds to the class, red class. And another one is W1 into X1 plus W2 into X2 plus B less than 0. That corresponds to the green class. And what is the separating line? The separating line is W1 X1 plus W2 X2 plus B is equal to 0. That is the separating line. And non-linearly separable data, in this case, if I consider, this is very difficult to draw the decision boundary. So this is one example of the non-linear separable data. So if I consider, suppose X or logic, there are different logic, N logic, or X or logic. In case of the X or logic, it is a non-linearly separable data that you can see. And one important theorem is the Kovar's theorem. So what is the Kovar's theorem? So in the next slide, you can see what is the Kovar's theorem. So if you see in figure A, I am showing the samples of two classes, which is not linearly separable. I am showing samples of two classes. One is the red, another one is the blue, which is not linearly separable. But if I apply some nonlinear transformation, nonlinear transformation into high dimensional space. So my input is the 2-dimensional space, and I am applying some nonlinear transformation, that is the transformation for the high dimensional space. So I am getting the 3-dimensional space. In high dimensional space, the samples will be linearly separable. That is the concept of the Kovar's theorem. In the low dimensional space, it may not be linearly separable, but if I consider the high dimensional space, then the samples may be linearly separable. So for this, I have to apply nonlinear transformation. So that is the concept of the Kovar's theorem. And in machine learning, one important is overfitting, underfitting like this. So first you can see I am doing the training and the testing also. First is, you can see I am showing the decision boundary between the classes. First one is underfitting, that is the inadequate. Next one is the good compromise. Next one is the overfitting. So in case of the underfitting, that is the high bias, the error is maximum for the training and also maximum for the testing. In case of the overfitting means high variance. The error is minimum for the training, but it is very high for testing. So that is why we have to consider a good compromise, that is between underfitting and the overfitting. So that concept I am showing here, one is the underfitting, one is the overfitting. So in case of the overfitting, for the training, the error is very minimum, but for testing, the error is very high. So that is why we have to consider the good compromise between underfitting and the overfitting. So again, I am showing the same concept. One is the underfitting, another one is the good compromise, and another one is the overfitting. So for this, I am showing the regression, classification, deep learning that I have shown. So you can see these cases. For deep learning, you can see if I increase the number of epochs in the training, you can see one is the underfitting case, the error is maximum. In case of the just right, that is very good. That is the just compromise. And also in case of the deep learning, also overfitting is also possible. So in the training, the error is minimum, but in the testing, the error is very high. So that is the overfitting. So types of machine learning, already I have explained. The supervised learning like classification, regression, unsupervised learning, clustering, dimension reduction like PCA, semi-supervised learning, already I have explained, and reinforcement learning. And for soft computing based machine learning, we can consider the bio-inspired computing. That is the inspiration from the human being, inspiration from the biological systems. Maybe we can consider the fuzzy logic, or maybe we can consider the artificial neural networks, genetic algorithms, genetic programmings. So this concept we can apply for the pattern classification for machine learning. That is, these are the biologically motivated artificial systems. So bio-inspired computing. So neural network concept already you know. So I have shown here, that is I am showing the dendrites, that is the structure. So it collects the signal from the cell body. So dendrites are like this, and all the signals are sum up. If the signal value is greater than a particular value, then the signal will be transmitted via axon. So this is the fundamental concept of the neural system, the biological system. So in my next slide, you can see. So you can see, so dendrites, it collects the signal from the cell body, and if the signal value, the sum of the signals are greater than a particular value, then I will be getting a signal in the axon, and the axon terminates at synapse. So in the second figure, you can see the signals are collected by the dendrites, and all the signals are sum up. And if this sum value is greater than a particular threshold, then I will be getting a signal in the axon. So this is the concept of the artificial neural network. So that is from the biological neural system that idea is coming. So if I consider a similar system in electrical system, so if I consider the electrical system, that is the model of an artificial neuron. So I have the signals S1, S2, S3, S4 like this. These are the signals. W1, W3, W. These are the weights. So what will be the sum signal? The sum signal is the signal is multiplied with the weights S1 into W1 plus S2 into W2 plus S3 into W3, like this. I have to do this. So I'll be getting the sum signal. If the sum signal is greater than a particular threshold, then I will be getting the signal S in the output. So for thresholding function, I am considering a squashing function. That is the sigmoid function I may consider. So squashing function I may consider, that is the sigmoid function. That is nothing but the thresholding function that I can consider. So this is the model of an artificial neuron. This is very similar to biological nervous system. So this is the squashing function, that is the sigmoid function. So this function is used for the comparison of the sum signal with the thresholding function. So sigmoid function is 1 divided by 1 plus e to the power minus x. So this is the sigmoid function. And in case of the artificial neural networks, you can see the weights are available in the artificial neural networks. In case of the fixed networks in which the weights cannot be changed, so weights are fixed. So dw divided by dt is equal to 0. That means the weights are fixed. So, but this is not so important. We need the adaptive network. In case of the adaptive networks, networks which are able to change their weights. That means dw divided by dt is not equal to 0. And one important point is the knowledge of the artificial neural networks is stored in the weights. Similarly, like human intelligence system or the biological intelligence system, suppose if I consider, suppose taking one umbrella. So for different conditions, suppose rain is coming in particular direction, so I have to move the my umbrella in one direction. If rain is coming in the vertical direction, I have to put my umbrella in the vertical direction. So that means I am doing my training. So all this training I have done, and this training is available in the form of weights in my brain. So suppose in a particular condition, suppose rain is coming in a 45-degree direction or any directions, I can adjust the direction of my umbrella. So that means the knowledge of the artificial neural network is available in the weights. So that is why the adaptive networks are very important, because dw divided by dt is not equal to 0. And knowledge of the artificial neural network is available in the weights. So this is the concept of the weights. The knowledge is available in the weights, the connecting weights, and the information is stored in the weight matrix. So I have the weight matrix, and the information is stored in the weight matrix. And in case of the artificial neural network also, we have the supervised learning and the unsupervised learning. The concept is very similar. In case of the supervised learning, we know what is the actual output. And so in case of the supervised learning, we know what is the desired output. We know what is the desired output, and also we can determine the actual output. The difference between the desired output and the actual output, that is the error. So error I can determine, and this error can be back propagated to the input to adjust the error, to adjust the weights, because I have to minimize the error. So that information is available. What is the information? I know the desired output corresponding to a particular class, corresponding to a particular training sample. I know what is the desired output, and also I can determine the actual output. The difference between the desired output and the actual output, that is the error. So I have to minimize the error. So that is why I have to back propagate the error to the network, so that I can adjust the weights of the artificial neural network to minimize the error. That is the supervised learning. In case of the unsupervised learning, this is nothing but the grouping. So some of the examples, like the competitive neural networks, that is one example of the unsupervised neural network. One is very popular, that is called the Cohen artificial neural network, that can be used for grouping. So this type of networks are available for artificial neural networks. One is the supervised, another one is the unsupervised. So basic concept already I have explained. So this is my inputs. I have the weights W1, W2, W3 like this. Fx is this. And you can see corresponding to this input, I can determine the sum signal. So signal is multiplied by 2.7, that is the weights. 2.5 is multiplied by 8.6 like this. So I'll be getting this value. And after this, I have to compare this with the sigmoid function. So what is the training? I can show you the supervised training. So already I have explained about the supervised training. So I have the training samples, and corresponding to the classes, I have the output. So output may be 0, 0, 1, 0. These are the outputs. Corresponding to the input 1.4, 2.7, 1.9, the output is 0. Corresponding to 3.8, 3.4, 3.2, output is 0. Like this, I have the outputs. So how to do the training? First, I have to randomly initialize the weights. So randomly, I have initialized the weights, and after this, I am considering the first training sample. The first training sample is 1.4, 2.7, 1.9. So corresponding to this, output is 0. So suppose in this case, I am getting the output 0.8. So what is the desired output? The desired output is 0. And what is the actual output? The actual output is 0.8. So what will be the error? The error is 0 minus 0.8, or maybe 0.8 minus 0. 0.8 minus 0. So error will be 0.8. So I have to minimize this error. So for this, I have to adjust my weights. So I am adjusting the weights of the artificial neural network. That is nothing but the back propagation I am doing. I am adjusting the weights of the artificial neural networks. Similarly, corresponding to this input, my output is 0.9, but actually the output should be 1. So what is the error? The error is minus 0.1. So that means I have to adjust my the weights of the artificial neural network. So I can adjust the weights of the artificial neural networks. And like this, we have to do this. So I have to minimize the error. So this is the weight adjustment in the artificial neural network. And you can see by adjustment of this weight of the artificial neural networks, I can find the decision boundary between the classes. So this is the randomly initialized weights, and I am getting the decision boundary for this. And after this, I am adjusting the weights of the artificial neural network, and I am getting the decision boundary like this. Like this, you can see, I am getting the decision boundary. And this is the final decision boundary between the classes. So this is the final decision boundary, I am getting this. So this is the training of the artificial neural network, and that concept is called the backpropagation training. So this is the concept of the artificial neural network. So already I have explained about this. Fx is a nonlinear function. And why this fx I am considering it a nonlinear function? Because I am considering the sigmoid function. So nonlinear function I am considering because with this nonlinear function I can get a nonlinear decision boundary between the classes. So if fx is a linear, then I will be getting only the linear decision boundary. Maybe the straight line I can get, or maybe the plane I can get. But since fx is a nonlinear, so I can get a nonlinear decision boundary between the classes. So that is why fx is nonlinear. That is the important point. And in case of the support vector machine, we can get the linear decision boundary between the classes. So I will not discuss in detail about these neural networks. So there are different types of neural networks. So one is MLP, the multi-layer perception, feedback networks, hope-filled networks, competitive networks, self-organizing networks. So there are different types of networks. So this is one example of the MLP, multi-layer perception. Input layer is available, hidden layers are available, and output layers are available. Input layer, hidden layer, and output layer is available. This is a simplest form of the feed-forward network. Here also you can see this is the input layer, the hidden layer, and the output layer. And you can see the interconnections between the neurons. So you can see the interconnections between the neurons. Another one is a feedback network. That means the output is fed back to the input layer. That is the feedback network. The hope-filled network is each and every node is connected to every other node. So you can see every node is connected to every other node. And you can see the symmetric weights. So what is the meaning of the symmetric weight? The weight from 1 to 3 is same as that of weight from 3 to 1. The weight from 1 to 3 is minus 2. From 3 to 1 is minus 2. So that means it is called the symmetric weight. Similarly, from 3 to 2, it is 1. From 2 to 3, it is 1. So this is the symmetric weight. So I'm not explaining in detail about the Hopfield network. And this competitive network, this is a kind of unsupervised artificial neural network. So this can be used for grouping. So for this, we have to determine the winner, which one is the winner. So we have to determine. So competitive layer is there. So we have the inputs, and I have to find the maximum value, that maximum output we have to determine with the help of this comparator, the competitive layer. That means I have to determine the winner. So this concept I am not explaining because time is less, only half an hour is available. I have to explain many things. So if you are interested, then what you can see, these concepts already I have explained in my NPTEL course in computer vision. What is the competitive networks? What is the coherent neural networks? So you can see my videos in the YouTube. In YouTube also it is available. So what is the competitive networks? What is the coherent artificial neural network? What is the fuzzy coherent neural networks? So these concepts are available in my YouTube video. So I think you can see these videos. And also this is the self-organizing network that is used for grouping, clustering. This back propagation already I have explained. The back propagation already I have explained. So how to do the training, the back propagation training. So here you can see corresponding to these inputs, I have to determine the error. The error is EJ. I have to determine. And after this, I have to minimize the error. So that is why I am determining delta EJ divided by delta WJ with respect to the weights. And I have to update the weights. So this is nothing but the back propagation training. Competitive learning also I have already explained. So you can see all this concept in my YouTube video. And the coherent neural network also, the concept is mainly the grouping, the clustering also you can do. So there are different types of artificial neural networks. So time is not available, so I am not explaining all these things. There are many types of neural networks, architectures, feed-forward network, radial basis function. RBF is very important. Recurrent neural network is available. The adversarial network is also available. So there are many types of artificial neural networks. So now I will briefly explain the concept of the introduction to deep learning. So traditional pattern classification problem already I have explained. So first I have to extract the important features from the input image. And after this, I can apply the supervised and the unsupervised classification techniques. So these features are the handcrafted features. So I can consider the shift feature, very important features, the scale invariant feature transformation. Hog means the histogram of oriented gradient. So these type of features I can extract, or maybe the color features, or maybe the texture features I can extract from the input image. So you see computer vision features, maybe you can see here from the input image, I can determine the hog features, the sheep features, or maybe the color features, the color histograms, the texture features. So all these features we can extract from the input image. So in traditional pattern recognition, you can see first from the input image, I can extract the handcrafted features. And after this, I can apply the learning algorithm. So maybe we can apply the support vector machine, or maybe the Bayesian decision making also we can apply. And deep learning already I have explained, this is nothing but the cascade of nonlinear transformation. So what is the difference between the deep learning and the artificial neural networks? Let us see. And you can see the performance versus sample size. If the sample size is very large, suppose if we have the large amount of training samples, then the deep learning algorithms, the performance is much better as compared to traditional machine learning algorithms. If we have the large amount of training samples, then the performance of the deep learning algorithms are much better than the performance of the traditional machine learning algorithms. This is the supervised learning. So here you see from the input image, we are considering the handcrafted features. After this, we are considering the trainable classifier support vector machine. After this, we are considering the outputs. Output may be outdoor or indoor, like this we can consider. So in the deep learning techniques, already I have explained, so we can extract many important information from the input image, from the input signal. So all the important information I can extract from the input image. So maybe we can consider the low level features. That means the low level frequency, low frequency we can extract. The mid level features we can consider. The high frequency information, that is the high level features we can consider. So all this information I can extract with the help of the deep learning techniques. And I have the trainable classifier, and we can do the classification with the help of this. So that means deep learning is nothing but the cascade of nonlinear transformation. So with the help of this transformation, we can extract all this important information from the input signal, from the input image. So here you can see from the input image, I can extract the low-level features, mid-level features, high-level features, and finally we have the trainable classifier. So input already I have explained. So deep learning, you can see the low-level features I am extracting, that like the pixel edges, mid-level features I can extract, high-level features I can extract, and after this the trainable classifier we can consider. So this is the deep learning techniques. So let us see how it all works. So let us see about the deep learning techniques. So if I consider a simple artificial neural networks, so what is the difference between the simple artificial neural network and the deep learning techniques? So let us consider these are simple neural networks, and you can see it is one input layer, one hidden layer, and one is the output layer. This is the simple neural network. And regarding the training of the artificial neural network, so we have to update the weights of the artificial neural networks, and that concept is the backpropagation training. So that is already I have explained what is the backpropagation training. Now let us consider these simple artificial neural networks. So corresponding to these simple artificial neural networks, I can consider the ReLU. ReLU is nothing but the maximum of 0 and x that we can consider. And we can determine the neuron output, neuron. So A11 we can determine. So A11 is nothing but the ReLU function, W1 into X1 plus W2 into X2, W2 into X, like this we can consider. So simple artificial neural network I am considering. Okay. So this is the ReLU function I am applying. And after this, if I consider the second layer, hidden layer, and after this I am considering the output layer. So this is a simple artificial neural network. And we can apply the softmax for taking a classification decision. So maybe we can consider this function, that is a softmax function we can consider for taking a classification decision. So if I consider number of parameters in a artificial neural network, number of parameters. So if I consider this simple neural network, so how many parameters? 4 into 4, 4 inputs, x1, x2, x3, x4. And you can see 4 neurons in the hidden layer. So 4 into 4 connections, 4 into 4. And connections between the hidden layer and the output layer. So how many connections? 4 connections plus 1 output layer. So this number of parameters we have to consider. So we have to do the training for this number of parameters, 4 into 4 plus 4 plus 1. But suppose if I consider one input image, the size of the input image is 400 cross 400 into 3. 3 means I am considering the RGB image. So we have to consider the red channel, green channel, and the blue channel. So size of the image is 400 cross 400. So if 400 cross 400, that is converted into 1D vector. The 400 cross 400 is converted into 1D vector. So it is x1, x2, x3. So what is the output? That is the x1, x2 up to x480000. So that number of input nodes are available. And also you can see the hidden layer nodes you can see. And we have the output layer. So corresponding to this, you can see the number of parameters. 48000 into 4800 like this plus 480001. So approximately 230 billions that we are considering. So that is the problem of the artificial neural network, because we have to train so many parameters. There are so many parameters in the networks. And if I consider, suppose number of hidden neurons, only 1000 suppose. So suppose 1000 neurons I am considering for the hidden layer. Even in that case also, it is approximately 480 million. So 480 millions or maybe the 230 billions parameters we have to train for the artificial neural network. That is the problem with the artificial neural networks. In case of the deep networks, we want to reduce this Now we want to reduce the number of parameters. That is the objective of the deep networks. So how to reduce the number of parameters? In case of the artificial neural networks, we have so many parameters, but in the deep networks, we have to reduce the number of parameters. So here you see, if I consider these neural networks, simple networks, input, hidden layer, and the output layer, and I am considering the sigmoid function. So first you can see 4 plus 2, 6 neurons, not counting the inputs. Input neurons are not counted. So 4 plus 2, 6. So how many weights? 3 into 4 plus 4 into 2, so 20 weights. And 4 plus 2, 6 biases. So that means 26 learnable parameters. So I think you know what is the importance of the bias. In artificial neural network also we consider a bias. So with the help of the bias, we can shift the activation function towards left or the right. The bias input is important because with the help of the bias input, we can do the shifting of the activation function towards left or the right. So the bias input is also important. So that means in this case, we have 26 learnable parameters. So many parameters we have to train. So that is why we have to consider the deep networks to reduce the number of parameters. So let us see how convolution layers help to reduce the number of parameters. So suppose in this case, if I consider this is the input image, and I am considering one filter, that filter I am considering, that is the high frequency filter. This is the Laplacian filter. So with this filter, I have to do the convolution. So with the help of this, we can do the convolution. So you can see how to do the convolution. You can see, I am moving the filter over the image. And the convolution also I am doing. Convolution means the multiplication and the sum up. Convolution means multiplication and the sum up. So I am putting the filter over the marks. I am putting the filter over the image, and I am doing the convolution like this. So with this help of this convolution technique, I can reduce the number of parameters. Because I will be getting the Fisher map I will be getting with the help of the convolution. So I will be getting the Fisher map after the convolution. So I can reduce the number of parameters because I will be getting the Fisher map with the help of this convolution operation. So here you can see, I am applying the convolution and I will be getting the convolved image I will be getting. So that means I am getting the Fisher map I am getting. So that means I will have the less number of parameters because simply I am doing the convolution. So what is the convolution you can see? So I am considering the filter. The filter marks is W1, W3, W2, W3, W4. These are the weights of the filter. So these are the marks corresponding to this filter. And I have to put the marks over the image. And I have to move the marks over the image. And I have to find the convolution. So first I am putting the marks over the image and I am determining the convolution output. So convolution output is this. So I am putting H1 here. After this, I have to move the marks to the next position. And after this, I am determining the second output. The second output is H2. And like this, I have to do the convolution. So in this case, the number of parameters for one Fisher map is only 4. So number of parameters for one Fisher map is only 4. And if I consider number of parameters for 100 Fisher map, it is only 4 into 100. So it is very less as compared to artificial neural network. So that is the advantage of the convolution layer. So we are discussing now the convolution neural network. And after this, we have to apply the max pooling and the average pooling. So what is the max pooling or the average pooling? So I am getting the Fisher map after the convolution like this. And you can see the max pooling means this neighborhood, if I consider the 4 by 4, if I consider the 2 by 2 neighborhood, the maximum value I am determining, the maximum value I am considering. So if I consider the 2 by 2 neighborhood 1, 3, 4, 2, so 4 is the maximum value that I am considering. Similarly, if I consider the second neighborhood 5, 3, 3, 1, so 5 is the maximum value. So like this, I am doing the max pooling. And also I can also determine the average pooling. So with the help of the max pooling or the average pooling, I can further reduce the number of parameters. So that is the objective of the max pooling or the average pooling. So how to reduce the number of parameters? The first one is by using the convolution, I can reduce the number of parameters. By using the pooling, max pooling or the average pooling, I can reduce the number of parameters. And also there is a concept of the stride. Stride means by how many pixels I can move the marks over the image. If I move the marks over the image by only 1 pixel, then the stride will be 1. If I move the marks over the image by 2 pixels, then the stride will be 2. So with the help of the stride 1, 2 like this, I can reduce the number of parameters. So with the help of the convolution, I can reduce the parameters. With the help of the pooling, I can reduce the number of parameters. With the help of the stride, I can reduce the number of parameters. So here you can see this is the artificial the convolution neural network. So I am considering the input image. First, I am applying the filters. That is the convolution filters. After this, I am applying the max pooling. Again, I am applying the convolution. After this, again, I am applying the max pooling. And max pooling. And like this, I am applying all these things. And finally, I have the fully connected layer in the output, and that is used for classification. So I may have number of filters, and I may have number of max pooling layers. So this is the convolution neural network. So you can do the classification like this: living room, bedroom, kitchen, like this you can do. So you can see here also I am showing the convolution. Move the marks over the image and you can find the feature map. That is the convol feature we will be getting. So with the help of the convolution, I can reduce the number of parameters. So this is the convolution I am showing here. So I am repeating this, how to reduce the number of parameters. One is by convolution. The second one is by considering the pooling. I can use the max pooling or maybe the average pooling. And also I can consider the stride. Stride 1, stride 2, like this I can consider. Stride 2 means by 2 pixels I am moving the marks. So this is the convolution I am doing. Like this I am doing the convolution. You can see how to do the convolution. And I am getting the feature map like this. I am doing the convolution like this. And corresponding to this input image, I am applying the high pass filter. This is a high pass filter, because with the help of this filter, I can determine the vertical lines, vertical edges, boundaries also we can determine. So with this help of this filter, I can determine the vertical lines we can determine. And this type of convolution filters we can consider. The low frequency filter, high frequency filter, now we can consider. These are the convolution filters. You can see we can consider multiple filters, and this is the input image, and we can consider multiple filters. And this is, you can see, I am considering a max pooling. 6 max pooling, you can see this is a max pooling. So 2 by 2 neighborhood is considered, and I am determining the maximum value. So max pooling I am considering. So like this, the pooling layer already I have explained. So this maximum value I have to determine, that is the output of the max pooling layer. So this is the structure of the convolution network. So I have the input image. After this I am considering the filter banks. After this I am considering the feature map I am determining. I am using the rectification, that is the ReLU activation function. After this I am applying the pooling layer. Like this, you can see the convolution network is like this: first stage, second stage, third stage, like this, and fully connected layers I am considering. Suppose if I consider this case, this is the bake detector. So that means, can this, if I consider this input image, so how to represent this image with the help of few number of parameters. So how to determine the bake detector? So this image how to represent by few number of parameters. So here you can see I am considering the bake detector. That is the upper left bake detector. Another one is the middle bake detector. So they can be compressed to the same parameters. They can be compressed because it is nothing but the bake. So they can be compressed. And this is the filter that is used for the bake detector. So we can consider this is the convolution filter that can be used for the bake detector. And we can apply the convolution filter like this: the filter 1, filter 2. So number of filters we can consider for the bake detector. And we can consider the stride 1, stride 2. You can see stride 1 I am showing like this. This is stride 2. The marks is moved over the image by 2 pixels. Stride 1 and stride 2 we can consider. One is stride 1, second one is stride 2. And I will be getting the feature map. So I can determine the diagonal lines. So you can see the response of the filter 1. The response of the filter 1 is 3. 3 means it is the diagonal lines I am detecting. So diagonal lines can be detected detected with the help of the filter 1. Filter 2 also, if I consider, so like this, I will be getting the feature map. So feature map I will be getting. And if I consider the color image, so for color image also we have to consider 3 channels, R channel, G channel, and the blue channel we have to consider, and we have to determine the feature map. So you can see the feature map we will be getting fully connected network, and after this we will be getting the fully connected networks. So image convolution I am doing, I am getting the feature map, and after this I am getting the fully connected layer. So with the help of this, you can see I can reduce the number of parameters. So that is the objective of the convolution neural network. We can reduce the number of parameters. And if I consider the interconnected neurons, then even also we can reduce the number of parameters. So if I consider the shared weights, sharing the weights, then in this case, the very, very less number of parameters we can consider. So with the help of the convolution, we can reduce the number of parameters. In artificial neural network, that is not possible. So this is the structure of the convolution neural networks. This is the image. Convolution I am doing, max pooling, convolution, max pooling. After this, I am just converting into vector, 1D vector. And after this, it is the fully connected feed-forward networks. And after this, I can do the classification. So max pooling, already I have explained. So 2 by 2 neighborhood I am considering, and the maximum value I am determining. So if I consider this 2 by 2 neighborhood, the maximum value is 3, 0. If you see here, it is 3, this is 1. Similarly, it is -1, this is 1, this is 0, this is 3. So this is the max pooling. Now, what happened actually? Max pooling means I am reducing the number of parameters. That is nothing but I am doing the sub-sampling. Sub-sampling I am doing. That means it is I am doing the scaling. I am doing the scaling. So that means if you see the input image, and after this I am doing the sub-sampling, the information content present in the image, it will not change. It will remain same. So that means the max pooling will not change the information content present in the signal, present in the image. So input image you can see, and after this I am applying the max pooling or the subsampling. That means the subsampling will not affect the information present in the image. So that is the concept of the pooling. So CNN already I have explained. This is the max pooling, and this is the convolution, max pooling, convolution, max pooling, and new image I am getting like this. So convolution, max pooling, convolution, max pooling, and after this I am doing the flattening, and I have the finally the fully connected feed-forward network for the classification. So flattening is, this is nothing but that it is converted into 1D vector, and after this I am just simply considering the fully connected feed-forward network for classification. So this is the concept of the flattening. This is from my book actually, my book on computer vision. So if you see my book, this also I have explained. This is the structure of the convolution neural network. So I am considering the convolution, a ReLU function I am considering. After this, the pooling I am determining, I am considering convolution, ReLU function, pooling like this, and finally I am considering the fully connected neural networks. And finally, these two topics briefly I will explain. What is autoencoder? Autoencoder is also very important. This is the artificial neural networks. So then generally it is used for dimensionality reduction. Like the principal component analysis, PCA is used for dimensional reduction. This autoencoder can be used for dimensionality reduction. So in this case, we have the encoder and the decoders. Here you see, input image is there, and we have the encoder. So one is the input layer, and after this the latent space representation, that is the bottleneck layer, and after this the decoder layer is there. So input, from the input image, I am doing the encoding, and I am getting the latent space representation, that is the bottleneck layer. And after this, I am doing the decoding. So I am reconstructing the input image. Suppose input image has noise. So with the help of this reconstruction, efficient reconstruction, I can reconstruct the I can reconstruct the input image. So I can remove noise. So here you can see the output image I am getting. This autoencoder is nothing but efficient data representation. representation. So data can be efficiently represented with the help of the autoencoder. So what are the important information present in the input image, input signal that can be extracted with the help of the autoencoder? So that is the concept of the autoencoder, and with the help of this autoencoder, you can reconstruct the original image. So just briefly, I will show what is the autoencoder. So suppose the noisy image is available, and you can apply the autoencoder for the reconstruction of the input image. The noisy image is available, so you can reconstruct the input image. This is nothing but efficient representation of the internal data. Efficient internal representation. So briefly, you can see noisy input image is this. So with the help of encoder, I can efficiently get the important information present in the input image, and that information I can do the encoding. I can get the encoding. I can get after the encoding, and that information I can consider for decoding for the denoise image. So I'm repeating this from the noisy input image. That is the most efficient internal representation of the input data. I am considering the most important information present in the input image, and that I am considering for the autoencoder, or that I am considering for the encoder. And after this efficient compressed representation of the input data, with this representation, I can reconstruct the input image. That means I can remove the noises in the input image, and I can get the denoise image. So what do you mean by efficient representation of the input data? What do you mean by efficient representation of the input data? That is the efficient data representation. So I will give one example, then you can understand. The encoder and the decoder, what is the meaning of this? Suppose if I consider this example, I am showing two sequences. So which one is easy to memorize? So one is the short sequence, another one is a very long sequence. It looks like this. The first sequence is easy to memorize as compared to the second sequence. Okay, but actually it is not true. If I consider the second sequence, the first sequence is it is very short as compared to the second sequence. So that is why if I consider the internal representation of the second sequence, so how to get the sequence, the second sequence? The even numbers are followed by their half, and odd numbers are followed by their triple plus. So if I follow this rule, then I'll be getting the second sequence. So with the help of these rules, two rules, I can get the second sequence. The first sequence, there is no possibility of getting any rules because these are random numbers, so I cannot determine any rules. But for the second sequence, I can determine the rules, and with these rules, I can represent the second sequence. That is nothing but efficient representation of the input data. So that is the objective of the autoencoder. That is the efficient representation of the input data. So you see, this is one example. So that is the position of the pieces of the chess board. So expert player, they can easily remember the position of the pieces in the board. But suppose one ordinary person, he cannot remember the positions. But this expert player, he can remember the position of all the pieces because he knows the internal representation of the data. He knows the position, the significance of the particular piece. So he knows everything. So that is why he can memorize the position of the pieces. But one ordinary person cannot remember this. That is the internal representation of the input data. That is the efficient data representation. So that is the objective of the autoencoder. So for this, we are considering the encoder and the decoder. And with this help of this, we can reduce the dimension of the input data. The same thing already I have explained. So that is the internal representation of the input data. Already I have explained this one. And finally, I will discuss one thing, the generative adversarial network. So in this case, there are actually two networks. One is the discriminator, another one is the generator. And there is a competition between generator and the discriminator. Okay. There is a competition. And the adversarial network means both network try to beat each other. And doing so, they are both becoming better and better. So they are competing each other. One is the discriminator, another one is the generator. So they are looking for the input images, real input images, and there are two networks. working parallelly, and one is the generator, another one is the discriminator. Okay, so I am not going to explain because time is very less, so I will skip this one. This generative, I am this one. For biomedical image analysis, this GAN is very important. So I am not explaining all these things. Now let us discuss within 10 minutes. So biomedical image analysis. So what are the importance of machine learning, deep learning in biomedical image analysis? So medical image modalities, you can consider the source of energy used for imaging, maybe the external source we can consider, internal source we can consider, or maybe the combination of the external and the internal. So based on this, if I consider only the external source, maybe the X-ray, radiography, X-ray, mammography, ultrasound imaging like this we can consider. In case of the internal one, we can consider the PET is very important. That is the positron emission tomography we can consider. Nuclear medicine also we can consider. And if I consider the combination of external and the internal, we can consider MRI, optical imaging we can consider, electrical impedance imaging we can consider. So this type of imaging we can consider. So here you can see chest X-ray, CT anatomy of human brain, fetal ultrasound image, PET of normal and abnormal human chest, MRI of human brain. So I want to share one important information in this case. So recently, actually, I'm doing a collaborative project with AIMS Delhi. So I have a collaborative project with AIMS Delhi and IIT Delhi. So we are actually investigating the chest X-ray of the COVID patients, those who have already recovered from the COVID, 6-7 months after the COVID. And what actually we are getting now, even after recovery of the COVID, after 6-7 months, the lung is damaged, 20% damage we have observed, 20-30% damage. I do not know when it will be recovered, but after the recovery of this COVID, we have seen 20% damage, complete damage in the lung. So we are getting almost 10,000 images from AIMS Delhi, and we are just analyzing all the images. So the intermediate results are like this. So we are getting this at least 20-30% damage. So last 2 days also I am very tense because I am having fever for very high fever. As today, fortunately, COVID is negative. My result is negative. So I am very happy now. So that is the problem with the COVID. So I think better not to take it very lightly, because it is very serious. We have seen. So all the images are with me. That is the chest X-ray images of the COVID patients. So this is the lung and COVID-19, chest CT, mammograms, Alzheimer diseases, PET, and tumors in the brain. And I am doing many researches on colonoscopy and the endoscopy, polyp detection in colonoscopy and endoscopy. So you can see in my publication list, I have many publications in the endoscopy and the colonoscopy. And currently I am doing on this COVID collaborative work, one that is a collaborative with Japan actually. So these type of medical images we are considering. So these are the medical images. So what are the challenges? So I think data acquired is homogeneous, limitation is time consuming. So there are many problems in medical image analysis and computer assisted analysis. So we have to develop a CAD system, that is automatic diagnostic systems, or maybe we can consider better visualization. We may consider AR and VR technology, augmented reality and the virtual reality we can consider, disease prediction, accurate and efficient diagnosis. Also all these cases we can consider. And there are many challenges in medical image analysis. You can see in colonoscopy also there are many challenging cases. So I will explain. So one important challenge I have observed, that is extraction of the foreground from the background. Background is cluttered background in case of the medical imaging, and very difficult to extract the foreground from the background. So one problem is the segmentation problem. And also if you see, whenever I put the colonoscope or the endoscope inside my body, so I will be getting specularity. Specularity means the mirror-like surface. Inside the body, the liquids are available. So I am getting the images that is very similar, that is the reflected images. Some mirror-like surfaces I am getting. So this is very difficult to remove the mirror-like surface. This is these are called the specularity, the specular surface. So we have to remove the specularity. Very difficult to remove the specularity in case of the medical image processing. That is also one challenge. And also, whenever I take the images inside the body, illumination changes randomly. If I put the camera and if I put some light inside the body, so illumination changes randomly, and it is very difficult to do the segmentation. And also extraction of the 3D information from the input image, that is also very difficult because we have the single camera. It is not the stereo imaging. So with the help of the single camera, it is very difficult to get the 3D information. So there are many problems in the medical image analysis. So one is the segmentation problem, and one very difficult problem is the specularity removal. Specularity means the mirror-like surface. So you can see here, and you can see here the mirror-like surfaces are available, and segmentation is a big problem. And polyp means we are considering the endoscopic images and the colonoscopic images. So endoscope we have to put, and the colonoscope also we have to put inside the body. And this is the retinopathy also we have considered. So steps in medical image analysis, that is, we can consider the specularity, noise. Also, we can consider we have to do some pre-processing, feature engineering. Also, we have to consider, and finally, we can make one CAD, the computer-aided diagnosis systems. We can consider. So, and also, I have mentioned it is very difficult to get annotated data, label data. It is very difficult to get in case of the medical imaging. So that is why most of the cases we have to apply semi-supervised learning. So we have to apply semi-supervised learning because supervised learning is not possible because we do not have the annotated data. So that is why we have to apply the semi-supervised learning. So this is one example of the polyp detection in the colonoscopic image. We can apply the supervised technique, unsupervised, and the semi-supervised technique. And you can see we can extract the features. Maybe we can apply the handcrafted features, or maybe we can apply the deep learning techniques also we can apply. So some CAD for some imaging modalities, like we can consider the lung cancer. Now one thing is the COVID detection, the breast cancer, mammograms, tumor in the brain, polyp detection, segmentation, classification. That is the colonoscopy we can consider. This is the mammograms, CAD for mammograms, CAD for lung cancer, CAD for brain tumors. So we can determine the brain tumors, and also we can do the classification of the malignant tumor and the benign tumor. So which one is the malignant and which one is the benign tumor, that also we can determine. These are the video. From video also we can determine. So this is the colonoscopic image, colonoscopic video. From the colonoscopic video, we can determine the tumor. But here the main problem is random illumination variation and also the specular surface. The specularity is present in the images. So that is also very difficult. So we have applied the particle filter algorithms for this. And this is the classification of the medical images. So we are considering the endoscopic images, and we are determining the cancers, the polyps in the endoscopic images. Very difficult to determine. So deep learning techniques also nowadays we are using deep learning techniques for medical image analysis. Deep learning already I have explained. For video, we have to apply some recurrent neural networks. I have not explained what is the recurrent neural networks, like LSTM. So I have not explained all these things, but for video also, you can apply these networks. VGG16, residual net 50, YOLO is also very important. YOLO is now very important. And also GAN, the adversarial networks, also very important. Autoencoders are also very important. So this you can apply. So like for deep networks, we can consider this one. And this is the structure of the deep networks. From the input image, we can do the segmentations. So deep learning modalities, you can see. Classification also, we can use detection, segmentation, other tasks. So deep learning techniques we can use. Diabetic retinopathy, also deep learning techniques are available. Classification of the skin cancer detections. So this is also one research problem, skin cancer detection. Segmentation of the brain tumor segmentation. There's a brain tumor segmentation. So also we can consider this one. And benefits of artificial intelligence. So there are many advantages of the artificial intelligence. So I think you know about this. So mainly there are some points. So I'm not going to explain all these things. And these are artificial intelligence in medicines. We can use of robots to deliver treatment, robotic surgery. So we can consider a robotic surgery. That in this case we need the artificial intelligence. So this is about my talk. So you can see some of my contents from YouTube video. That is the NPTEL course. So my book is also available in computer vision. So that is the fundamentals in computer vision and image processing, fundamentals and applications. So many things I have explained in my book. And one is the NPTEL course, and one is also another web course, and that is also on computer vision. And my second book will be coming to the market. That is Advanced Machine Learning and the Deep Learning Algorithms. So by December it will be coming. So this is my book. So thank you. So fortunately I could complete 2 hours of my talk. Initially I thought that I cannot complete. So thank you for this.
Thank you, sir. Any question from participants? Please raise your hand. I will unmute you. Otherwise, you can write the question in chat box. Any participant having any questions? No. No question from participant. Any participants? If you have question, please raise your hand.